organ which we need to focus in order to understand integration of metabolism is adipose tissues. Roughly, we will have about 15 kilograms of adipose tissues. This is for a 70 kilo weight human being. Adipose tissue is so strange that they do not replicate when we become an adult. So what can happen to an adipose tissue is, over a period of time, when fuel molecules are plenty, they can keep increasing the size. In the first figure is a scanning electron micrograph of a fat cell. Look at the size and the shape it takes. In the second figure is a photomicrograph of a fat cell. Look at how the larger portion of the volume of a cell is occupied by the triacylglycerol and how it has pushed the cytoplasm into one corner, and you will also find the nucleus is also pushed into one corner. So this is how fat will be getting accumulated in the adipose tissues. And adipose tissues can store roughly about 135,000 kilocalories of energy. That is quite a lot of energy in order to survive on a starving mode for about 3 months. As we are aware, there are 3 fuel molecules which are fat, protein and carbohydrates. We also know that oxidation of fat will yield about 9 kilocalories per gram. Protein and carbohydrates will yield about 4 kilocalories per gram. When we look at the table where these fuel molecules are distributed in the body, for example, blood, liver, brain, muscles, and in adipose tissues, our focal point at the moment is the amount of energy available as a fat. In adipose tissues, glucose and glycogen will make up only about 80 kilocalories. Triacylglycerols, that is about 135,000 kilocalories, will be the net yield from the 15 kilograms of adipose tissues. Mobilizable protein will be only about 40 kilocalories. This data is exactly shown in the pie chart given here. Look at the large area that has been covered by the amount of energy given by or stored as adipose tissues, and the small fraction of energy as glycogen or as protein which is present in the adipose tissues. So adipose tissue, it is a storage house. Adipose tissue lack one enzyme. That enzyme is glycerol kinase. Adipose tissue is a glucose sensor. When glucose is plenty, adipose tissues identifies that, then it will slowly begins to synthesize DHAP and glyceraldehyde 3-phosphate. These molecules are required for the production of triacylglycerol. So we know that 3 free fatty acids are attached to glyceraldehyde, glycerol 3-phosphate, and that is how triacylglycerols are synthesized. So therefore, depending on the glucose level, the adipose tissues get into a synthetic mode, and the triacylglycerols will be stored in the adipose tissues. When we switch over to a fasting mode, in the triacylglycerol lipase, this enzyme is activated, and as a result, this enzyme will act on the triacylglycerol. Free fatty acids are released. They will bind with albumin, get circulated, and it will go to those tissues where oxidation of fatty acid must occur. When a triacylglycerol is mobilized or degraded, if the glycerol which is formed, since there is glycerol kinase absent in the adipose tissues, if the glycerol will be transported to liver, where glycerol kinase is present, so that glycerol will be converted to energy. So 5% of energy that we produce is derived from the glycerol that is present in the adipose tissues.